This is Halil. I will briefly present our research on smart surveillance and edge computing. We want a surveillance system where intruder cannot tamper or remove evidence. Solution: backup evidence, for instance, on the cloud. However, we want to minimize bandwidth and cloud costs. Solution: store only relevant information. Okay, we want to identify relevant information from stream of surveillance data. How do we do that? Face recognition. If the person is recognized locally, no need to store that evidence on the cloud. Otherwise, upload it. We want to prevent single point of failure in this design. A point of failure occurs when a single server is no longer functioning and bringing the whole system down. We have the following constraints. Solution has to be cheap and offer sufficient processing power for face recognition. Solution: use single-port computers such as Raspberry Pi. Proposed design consists of 4 layers. We will go over those layers briefly. Cloud layer consists of multiple cloud components from AWS. We use Docker as containerization technology, Pi 0 for pre-processing and Raspberry Pi 3B for processing layers. We utilize Python as programming language, OpenCV for face detection, dlib for face recognition. We use an open source Python library face recognition as dlib convenience wrapper. We open sourced all our work on GitHub and all containers are available on Docker Hub. We used a pre-trained model of 3 million faces of 7485 individuals. We captured 363 photos of the household as dataset. We created 128 dimensional representations of the household dataset, and we persisted that representations to our database. Device layer consists of sensors and actuators. In this work, we used IP cameras. Pre-processing layer, we used Raspberry Pi 0. This layer connects to one or more IP cameras and receives surveillance data over RTCP protocol. It performs face detection to reduce the bandwidth to the processing layer. When a face is detected, it uploads to the processing layer. We use hard feature-based cascade algorithm for face detection. Processing layer. We use Raspberry Pi Model 3B in this layer. It receives cropped faces from pre-processing layer. We use a simple round-robin load balancer to orchestrate traffic to 4 nodes. This layer performs face recognition. If the face is recognized, it persists the result in a NoSQL database and disregards the frame. Otherwise, it persists the result and evidence on the cloud. Cloud layer. We use Amazon Web Services as a cloud vendor. Processing layer uploads unrecognized faces to an object storage, S3. We perform face recognition that cloud offers as a service. We use 2 reference photos of the household in this service. A serverless Lambda function is triggered by S3 changes. It calls face recognition API, which is known as AWS recognition. Results are stored in a NoSQL database. We use simple notification service to consume results of this API call. We left alerting the household as a feature work. Experiments. We implemented and deployed this design to author's living room for 2 months. It captured 11,587 faces, including many false positives, such as the ones that you see on the slide. We fine-tuned the hard cascade parameters to camera position and environment. That resulted in 4,032 faces. We use Google Photos to compare accuracy of our system. Google Photos revealed that 1,291 photos of Isenur and 1,423 photos of Halil. They were in the same frame in 14 photos. The remaining photos included other people in the household and some false positives. We exported the NoSQL database to a MySQL in order to perform in-depth analysis. We found that 93% of faces recognized on the edge without need to upload to the cloud. Success rate of overall pipeline becomes 98%. Elapsed time to perform recognition is similar for both processing and cloud layer. Conclusion. We created a Dockerized open source recognition platform that runs on Raspberry Pis and works with any IP camera. We verified that Raspberry Pi is a first-class citizen in Docker and can run containerized applications out of box. Our design can work over Wi-Fi. We use cloud for persistency and redundant recognition platform. Our design makes it trivial to add new faces to a known faces dataset. Results show that our implementation is slightly better than AWS recognition. Overall pipeline performs better than each method alone. Thank you.